Okay, now I'm recording. I will share my screen and we will start. Yep. And now, perfect. Can you see my screen?
Yes.
Okay, good. So let's start. So today's lesson it's about deployment. Okay, I will explain you in what consists deployment and what options do you have normally to deploy a machine learning model. So first of all, I would like to start with this question. Okay, imagine that you have been hired by a bank. Okay, for example, to create a model to classify if a new client will pay the mortgage or not. Okay, suppose that you receive a report with the accuracy of the model that the bank already had, and they ask you to try to improve it and to have a better machine learning model to increase their revenue and increase their profit. Okay, so you have been asked to do that. You do all the job. You do all the data cleaning, all the process of the ChrisDM methodology that Ernestina has been explaining you during the previous lessons, and you have everything ready. Okay, and if you remember, there is several steps. Okay, and one of them is the deployment of the model. Okay, so the thing is that you did everything, you have your model, it's working, it's perfectly, you get a really good accuracy, whatever, you evaluate it and it's okay. Now, what are you going to give to the bank? It's my question. What will provide to the bank? What are you going to give to the people of the bank? This is an open question. I would like to ask you to give me your opinion.
It depends a little bit on what the bank wants. Do they just want the model, or do they want the application to use the model?
Okay.
Or maybe like a dashboard or something. It kind of depends what they want.
Okay. Good answer. That's a good answer. The thing is that imagine that they want something that can be directly used. Okay, so if you give the model to them at the end, what you are going to give is maybe a file with the serialization of the model, maybe even the code that you have been using for creating such model. But the thing is, do you think that the model itself or even the code to create the model is something that they can directly use? And with them, I refer to the final user that probably will be, I don't know, the director of an office of some bank, of some office or something like that. The thing is that, do you think that this is something that they can use directly?
I think the director does not have any use for it directly at all, because they don't know how to read the model, or they have no experience in the field you've been doing this, or so basically they don't have any use for the model itself.
Okay.
They just want to know what it gives.
Yeah, perfect. That's the idea. They want to use it, so they don't want to worry about what is behind. Okay, behind the answers that the system is going to provide to them. At the end, the director of an office, what he or she wants, it's okay. I want an interface where I can put all the input data of my clients and I get back the result. Okay, that's the idea. So the thing is that when you are doing machine learning models, as Ernestina was explaining, and as I said before, there is a complete cycle of different steps that goes from the business understanding until the deployment. Okay, being the deployment, I will say the last phase. Okay, but not really. Indeed, it is the last phase of the cycle, but it is a cycle that at the end can be, let's say, endless, okay, because it will need probably evaluation in the future of the results, etc., etc., okay. But the thing is that, of course, you need to provide something to them that it's useful. So here is where we came to the deployment of machine learning models. So my idea today is just probably you already know about deployment, and probably there are many things that maybe you already know, but the idea is to show you what is the steps that normally we do in the deployment phase, and what we are going to show you is some examples and some frameworks that can be useful for deployment of machine learning models. I put this picture. I really like this picture, and I put it here in the deployment phase because I think that at the end, what you are going to, well, of course, we already know that when we are using machine learning, artificial intelligence, at the end, we are always working on the background of mathematics and statistics in particular. So the thing is that what we are going to sell at the end, and this is why I also put this, I mean, this image can be, of course, interpreted in several ways, but in the context of deployment, what I want to focus is in this last part where I show to the public what I did, okay, and this is where I show this artificial intelligence model that it's going to be used by let's say not the general public, by the final user at least, okay. So the deployment phase, the objective to allow that the models can be used in a real environment. When we are doing machine learning and when we are doing data mining as methodology, let's say, we are creating a set of models that we evaluate and we improve, we optimize, and at the end we have something that after a careful evaluation we consider that can be useful, okay, and can be used in a real environment. But the thing is that, as we discussed at the very beginning of the class, the model itself or the code that at the end creates such model, it's something that cannot be used by the final users, okay, unless your final users are also experts in the field that knows exactly how to run this Python or R code or Java or whatever in order to give to the model a new input and get the output. But this is not the normal case. I mean, as data scientists, your work goes from the very beginning of getting the data until the very end of deployment the machine learning model. It is true that at some point or in some cases the deployment phase might not be your responsibility, okay, but it's something that you need to take into account that might be some of your tasks. So the models are trained for its using. Of course, we don't create the models just for nothing, okay. In the real life, okay. Of course, when we are maybe here at the university with this in this subject, we ask you to create a model that, to be honest, will not be used far away from the practical setting of practicing this subject, okay, or practicing to doing some machine learning models. But in the reality, the models are created to be used. Something that we need to consider is that it might be necessary to train the models again depending on the changes of the data. Imagine the case of the mortgage. We create a model, okay, to improve the actual, let's say, accuracy of the bank models, but maybe in a few years this model is, I will say, outdated, okay. It's something that it's not working properly. Why? Because the data changed. Not the data changed, the real environment or the real life changed. I mean, the thing is that maybe the economical situation in 10 years will not be the same, and for example some of the variables that we are using as inputs have changed such a lot that it's necessary to consider the creation of a new model, the retraining of the model, or maybe there are other variables that are important in order to know if a client is going to pay the mortgage or not. And I'm focusing on this example of the mortgage, but can be of course any example of any domain. Okay, the thing is that when we have such changes, it might be necessary to train the models again, and we have several options. We have online learning option when possible. Not all the algorithms allow, for example, to do online learning, or train again everything, reevaluate the model. So several options came to our mind and can be executed. Depending on the, let's say, type of demand that we have and the learning that we have this, let's say, matrix where we have that, for example, depending on the context of having dynamic data or having real-time data or having on-demand data, we can focus on different types of deployments. Okay, so for example, one of the most typical, and I think one of the most typical, and indeed in the one that probably we will focus more on this class, because I think that it's the most not the most relevant, but yeah, it's the most typical case, is when we are learning, doing a machine learning model that we train in an offline setting, which means that we have a set of data that probably might change in the future, but that didn't require, okay, to be trained or to be reevaluated continuously, and where we want the predictions on demand. It's like, okay, I have a new client, I give the data to the system, and I get an answer. Okay, and this is the typical case of the web service. However, there are other settings, for example, in the same case where we have an offline learning approach where we create our model, but the prediction is made on batch, okay, which means that, for example, we have a set of new inputs, okay, that we give to the machine learning model, and we get the result at some point, but it's not real time, okay, and this is when we are talking about forecast. In this case, in the left part of the square, we are assuming that we have, let's say, more or less static data. Okay, as I said, this static or dynamic depends on the learning part, and means that the data that I'm receiving or the data that I'm using to create my models are not changing. Okay, or at least they don't. The data that doesn't have a change that it's very, I will say, very fast or very quick. On the other hand, we have the online learning, and we have, for example, the dynamic creation of the data, where we have more data that it's not created, but can be used for my model. And we have, on one hand, online learning, when I want, for example, a real-time let's say, response or answer to my model, but also I have a, let's say, more or less real-time change in my data, and for hence I want or I need to update my model continuously. Okay, and on the other hand, when I have, let's say, dynamic data, but I don't need let's say, on-demand or real-time predictions, we are talking about automated machine learning, which means basically that we can somehow update such models in batch, okay, and not continuously. As I said, the most typical case in most of the domains that probably you will face, I will not say in your real work, because it depends, of course, where are you going to work, but I will say that most of the cases are focused on the part that it's in the web service part. Okay, that it's that I have data more or less static, and I need okay, on-demand prediction, but the data is not changing so fast that I need some other approaches. Okay, and this deployment phase or this deployment class will focus more on this side. Okay, so problems. Okay, well, this is a picture so that I find that I think It's funny. When when the developer tests, everything is okay, everything is fine. It's, I mean, working perfectly. When the quality team tests, okay, some warnings. When the project manager tests, okay, blue screen, typical Windows blue screen, like everything has crashed. And when the customer test, is that okay, the case where nothing is working, and indeed it's probably doing the contrary that we were expecting. Okay, this is something that we need to consider also in the context of deploying machine learning models. Okay, there are some problems that we will identify now. So the first one, it's multiple data science language. Okay, so you know that there are some programming languages that I will say that are very, very, very used by the industry. For example, C++ or Java are probably some of the main programming languages that are used in the industry. Of course, that some other programming languages like Python or I don't know right now, or C Sharp or .NET environment or Ruby or Perl or whatever are of course also used. But the reality is that most of the industry, when you see developer positions, they ask knowledge about these two programming languages because are the main ones. Okay. However, the thing is that probably in data science, most of the things that you have been doing were done in Python or in R. Okay, and the thing is that the problem is that we are mixing both programming languages. Okay, because maybe we did our model in Python, we did all the data manipulation, all the everything in Python, but now I need to integrate my machine learning model in a Java environment. So how can I deal with that? There are several options, of course. You can call Python from Java. You can create, let's say, a small, let's say, microservice within your architecture that can be part of the main architecture, and Java can call or make petitions to this microservice that was made in Python or in R. Okay, the thing is that there are several options, but making all these things working together is not trivial. Okay, it's not a trivial option. Some other problems. Data science languages can be slow. Okay, as I said, Python and R are probably the most popular languages, but in production, for speed reasons, normally it's not common to deploy the models using these programming languages. Okay, so we need to port, for example, a Python or R model into a, let's say, production language like C++ or Java or any that or customer can require. And this is something that is challenging and sometimes implies a reduced performance of the original model. Okay, this is something that we will see some options indeed to port Python and R models to other programming languages. Well, depending on your company's capacity, and this is something that I think that we had a ML Ops session at the very beginning of the course, and this is something that we need to consider. Depending on your company's capacity and goal, it might be a bit challenging to choose the best architecture, and maybe that means that we will require some let's say profiles more focused on DevOps or machine learning ops. It's something that is right now very, very popular also. Okay, so the machine learning architectures that we have, this is indeed a summary of this square that we saw. Okay, train by batch, predict on the fly, and serve via REST API. We train and persist. The training and persisting is something that we did or we do offline. Okay, we are not doing it online, and the prediction is on real time. So we train the model, okay, we do all the things, we deploy it, and we can ask the model, for example, using a REST API. As I said, this is probably the most common scenario. Train by batch, predict by batch, and serve through a shared database. Okay, this is the case that we have in the left part at the bottom. Okay, and it's more the, let's say, the forecast approach. We train and persist. Both the training and persisting are done offline, while the predictions are in a distributed queue, which it's almost similar to real time, but it's not real time, because the difference is that in this case the model is query, okay, and all the predictions are stored in a database, for example, and you can go to retrieve the let's say the answers or the results of the predictions directly from the database. Okay, you are not getting a real-time prediction because you are not you're not querying the model to get real-time response. Well, train predict by streaming and train by batch predict on mobile or other clients. Okay, this is basically, for example, when we are talking about doing prediction on the customer device. Okay, the model is transferred to the device, and this allows offline use. This is something that it's probably a bit more let's say uncommon, and it depends on the of course on the architecture that we are managing, because at the end what we are aiming here is that I create my model and I transfer it to a, let's say, device where I can just make locally all the queries, okay, all the queries to the prediction model. Well, to the model, I mean prediction. I will not say prediction, maybe prediction in terms of classification, regression, or whatever. So this is basically the summary, okay? Well, this is the high-level architecture of the machine learning architecture in terms of the deployment phase. Okay, we go from the data layer to the evaluation layer. Okay, so the data layer is basically that provides the access to all the data sources. Okay, the feature layer is the responsible of generating the feature data in a transparent, reusable, and scalable manner. This is important. And this is really important indeed. I will stop here a second. When you create a model, it is, imagine that you receive the data from the bank, okay, and you receive I will say a database, a MySQL database with, I don't know, let's imagine 200 variables, 200 columns, okay, and a number of rows that it doesn't matter. The thing is that from these 200 variables, probably you're not going to use all. Okay, maybe you did a feature selection, maybe you discard some variables because they were senseless for your approach, and maybe you only are going to work, imagine, with 100. But even with this 100, it is possible that you made some changes on the original variable and now you are using a derived variable, okay, or you convert the original data from one variable to different types of data. Imagine that you make a discretization of the data. You get a variable that was a continuous variable, and you decide it based on the values to make a categorical one. Okay, so you discretize such variable. This is important because when you are going to query your model, the input data that you are going to receive is the same input data that you receive at the very beginning, okay, in the data layer. And it's important to make these conversions to the appropriate features or appropriate variables that are the ones that at the end will be used to query your model, and indeed are the ones that were used to create your model, okay, to train your model. So from the original data to the data that finally you're going to use in your model, it might be some conversions that needs to be done even in the prediction phase, okay, and this is important. The scoring layer, okay, basically transforms the features into prediction. Here is when we do, the query to the model, okay, to the training model to get the prediction. And the evaluation layer checks the equivalence of two models, okay, and these can be used, for example, to monitor the production models. So to see, for example, how closely the predictions match the training prediction. The evaluation layer is important because it basically represents the measurement of how my model is behaving, okay, and it will give me some hints about if I need to update my model or not, okay, at some point. So this evaluation layer is something that you need to consider. Here basically it's the let's say a more in detail version of the architecture. The first thing is that we have on the right part the development phase, okay, where we are basically we are referring in this case with this CI/CD pipeline with the continuous integration and continuous delivery, okay. It's from a methodological perspective. And on the right part what we have is, let's say, the development phase, okay, where we have all the typical steps from the training data to the feature structure and the model builder. And in the production, okay, we have basically the same. So it's important that from the development to the production we have a complete map, okay, between all the steps. This is important, again, as I said, for example, in the context of the feature structure. The features that we are using to create my machine learning model are the same features that I need to use in order to do my predictions in my created model. And finally, well, what we have here is that the instead of the REST API that allows me to get, for example, the different data, is the REST API that allows me to do the prediction. Indeed, you can see that below the post / predict, what we have are the clients. Okay, so the clients allows me to create a petition, okay, against my model that has been deployed using a REST API and get the results. And well, finally, as I said, this is really important, the feature structure, since we need the same inputs, okay. So when we go to production, it's important that we have these three we have these not these three, sorry, we have these 6 steps, okay, but it's important that these 3, only the circle parts, are the ones that goes to production, okay, are the ones that at the end needs to be focused on the deployment phase. The feature engineer, that it's part of the data preprocessing, the variable selection, and the model building or the model querying, okay. Well, most of the typical use cases are based on the development of an API, REST API, as I said, where the model are trained locally and it is deployed and accessed via request to the API, okay, or through a graphical use interface that makes such request. Coming back to the question that I asked at the very beginning of the class, it's important to take into account that even, for example, creating an API, a REST API that allows to query the model, I mean, this is something that is considered under the deployment phase, okay? If you did that, I mean, if you are able to just, if you are able to at least deploy your model and create a REST API that allows to query your model, that's enough to consider that your model has been deployed, okay? But take into account that, imagine the situation again, if you sorry, I love because I am laughing because I imagine the situation. Imagine that you go to the director of the office of a bank, and what you give to them is, okay, this is the URL where you need to give me your JSON files with the input to the models, okay, and basically what you need to do is a post petition against this URL, okay, where I have deployed the REST API. What you are going to receive as output is another JSON file where you are going to receive just 2 variables. One is the prediction result, the class, and the other is the confidence of the prediction. And I can imagine the guy in the bank office, probably a guy that didn't know what is a REST API. Maybe, I mean, probably he only will understand the URL because he also knows what is a URL. But probably he will not understand what are you referring with JSON. He will not understand what are you referring with API. He will not understand what are you referring with REST, and he will not understand what we are referring with POST. So the thing is that in some cases, deploying your machine learning model in a REST API is not enough, okay? And you might need to provide to this final user something more not useful, sorry, I will say something that for them are easy to use, okay? And a REST API will not, because you are not going to say, no, it's very easy. No? You download Postman, and with Postman you create the JSON file, and with the JSON file you give me the input in a JSON file. I can give you the template, don't worry. Even take into account that you need to input me 100 variables, okay? But you do it in the JSON file and you send me through Postman and I get the response. No, okay, that's not the case. But again, probably in some cases, creating a user interface to query your model is not your responsibility, okay? It's not your final responsibility. However, in this class, what I'm going to show you are some tools, okay, and some frameworks that allows you to go from the very basic case that is the REST API to, for example, creating a small graphic user interface, okay, like for example with Shiny Apps in R or with some other frameworks that I have prepared in Python, that allows me to create a very basic user interface, at least to, give me the age, give me the whatever data, okay? But even with that, take into account that the graphical user interface, I mean, if your deployment is REST API and there is a graphical user interface that will connect from your user interface with the REST API, another thing that you need to consider is that you need to ensure that the graphical user interface that has been created only will give to my REST API the required type of data. Because imagine that you have a model that, requires 20 variables, okay, just to make a prediction, just 20 inputs. And 20 inputs is basically a text box, okay, variable 1 and a label, variable 1 and a text box to put the input, okay? And you do the same with the 20 variables. My question is, what do you think that can happen if you do something like that? If you give to the final user something as easy as 20 labels, 20 text box to input the 20 variables that you need. Do you think that this is a good option or a good practice? What do you think? It's just to not talk myself only. Do you think that this is a good practice to give just an interface as simple as giving only the name of the variable and a text box, a simple text box?
I think for most of the cases, yes.
Sorry?
For most of the cases, yes, because for example, Shazam or other applications, they just give you an API and you call it and you take the final prediction.
Okay, agree. But imagine that, for example, my question was oriented in the context of, can you trust in the input that the final user will give to this text box? That's my concern. Of course, it depends on the type of variable. I mean, if all the variables are just, imagine, alphanumeric variables, it is normal that you put text box. But the thing is that my intention with this question was, you need to be as much careful as possible with the input that the final user can provide to your model. Because imagine that one of the variables, it's a date, and the other, instead of a text box, it's an option between 4 options. It's a categorical variable. If those cases, imagine that these 2 variables are present, what are you going to give? A text box where they can input anything, or maybe you use other type of interfaces to give the data? What will you do? Do you still maintain that it's better a text box, or maybe you prefer to give not only to give for these variables the appropriate type of data? Because if one is a date that needs to come in the format day/month/year, if you allow to write anything, maybe he write it in the format year-month-day, that it's with different separator between the month, the day, and the year, and with different format. Okay, so what I was referring to this is that when you provide a REST API, it's okay, but if you provide a user interface, you need to be as much careful as possible in order that the inputs that the user are going to give to your interface are the inputs that are expected. I don't know if you raise your hand for a second. Okay, it's just that. Okay, it's just that because I remember when I started in the university, I had a professor that he says very often that the final user is an idiot. Okay, the final user. I mean, if you in a text box are expecting a date, maybe he will write any other thing that is completely different than a date. Okay, and he was basing this idea on this that they are idiots. Yeah, tell me.
Still, in some cases, that text box is our unique solution. But in some cases, we have this opportunity to use that specific values. For example, I still come back to the Shazam application. In Shazam application, it's same as that text box. We let the user to give us sound, but still in the client side in the application, we check the type, everything that we send to the user. But in some cases, for example, in recommendation engines, the data is generated completely by the application, so there is no worrisome about how will be the type of data on other things.
Okay, I got it. Yeah, of course, it depends on how is at the end the application, how was developed. Okay. And as you said, there are several options, and there are several in several places where you can control these things. Okay, but it's just an advice. Okay, that as much as you can at some point, let's say, verify or check, the better, because at the end this slide that I showed before about this image, okay, this image, when the customer test, sometimes this explosion of the entire world, it's based on these problems, okay, because we allowed to give some inputs that were not the appropriate, and we didn't control appropriate that these inputs were given, okay, and it's when everything started failing. It was just a comment, but I agree with you that of course there are several places where you can control this situation. Okay, so well, this is something that we have discussed basically. So final users will use the deployed model or machine learning model by using an interface that allows an easy input. Okay, the idea is that you cannot ask your final user to write inputs in a CSV or on a JSON. It's what I was explaining with the example of the bank office director, that you cannot go through this path. Okay, so you need to limit the inputs. This is what we were discussing, as much as possible to the expected inputs. Okay, Another thing is that the output values must be also meaningful, okay, or must be shown in a meaningful way to the final user. So it depends on exactly your machine learning model, okay. But this question about how will you provide the output of your well, I was writing all the time ML when I refer model, okay, indeed. The output of your model. This depends, of course, on the output of your model. In the case of the mortgage, for example, that it's if a client is good or not, then you can go from the very basic answer that it's is the client going to pay back? Yes, no. Okay, that's the simple way. Is the client to pay back? Yes, no, and with the, let's say, sorry, I don't remember another word. The confidence of the model, okay? Yes, no, and the confidence value that the model return. But you can go further, okay? You can go further. You can give, of course, the answer of the model, but you can maybe show some additional data, additional statistics that allows you to understand better why the decision was reached. Or, for example, you can imagine that you have been using a specific machine learning model, a decision tree, okay? Maybe you can even show, for example, the render of the decision tree, and you can show to the final user, okay, this is the answer that I give you, but I explain you, okay, and this has also to be has relation with the concepts of explainability, okay. The concept of explainability is something that we also need to consider when we are doing a machine learning model, and when we are deploying of a machine learning model, it's something that it should be on our minds, okay. It should be on our heads, that maybe, if possible, we can show to the user not only the answer of the model, but also some additional explanations. The additional explanations can be derived from the model itself. For example, if the decision tree is a case where I can get a visualization of how the decision is reached. But in the case that it's not like that, imagining a neural network model or in a deep learning model, we also can show, for example, some statistics that are derived or are related with the decision that has been taken, okay? And this is something that is also useful. So just take into account that the deployment and the answer that is given to the user, it's not just a question, or it's not just giving me the value, okay? It's something else. So, well, output values must be so rendered in meaningful way, understandable way, confidence values, some explanation, etc. Okay, so we move to the next part, and with that we go, because what we saw until here, it's, let's say, a more high-level explanation of the deployment phase. We have been seeing the different type of deployment options that we have depending on the type of data that we have, on the type of predictions that we want, if it's real-time or not, etc. Okay, this is square that we saw with the other table that was a little bit expanded, okay, with more information. But now we will start entering a little bit more into the technical part, okay? I will not show you too much information in the technical side. I will give you some fragments of code that I get from the documentation of the libraries that I am going to show you, okay? This is not something very complex, but my idea is just to show you what options do you have. And the first thing that we need to consider, once we have created our machine learning model in development, okay, once we have evaluated it, what we need now is to go to the model serialization. Because, when a machine learning model is trained using a code in Python or in R, okay, for example, the model only lives, okay, during the execution of the program or the script. Once everything is finished, there is no model, okay, unless you do something. So the thing is, what happens when the code finishes? Okay, it disappears. The model disappears. Okay, it was on memory. Okay, in the memory of our computer. But if you don't do anything else, okay, if you imagine that you are in Python, you execute the feed function. Okay, you train your model and make some predictions over the model to test it or to just do whatever. But once it's over the code, the model is over also. Okay, it's no longer existing, so it disappears, and the only way to maintain it is to save it in a file. Okay, serializing it. So different programming languages and frameworks provide different solutions to store or serialize the models. Okay, serializing the model allows us to open it and use it in a different context or later. Okay, and for example, the objective that we are aiming right now, that is deploying it. Okay, to deploy our machine learning model, I need to save my machine learning model. Okay, so some options, okay, that you have. Well, there are several formats. Okay, there are several formats, and there are some formats that are, let's say, more I will say, well, that has been developed for many years and are somehow standards. Okay, the most popular, or one of the most popular, is PMML. Okay, that is predictive model markup language. That basically is an XML based structure or format to represent mining models. Okay, you can see the structure and the general documentation in this website, but the idea is at the end that, for example, when you create a machine learning model, you can export it to this PMML, and what the file contains at the end, for example, are, imagine in a neural network, the different weights of the different neurons, or the different values of the entropy. For example, in the case that you create a decision tree using the entropy for the information gaining, or in the case of the ID3, or the different let's say values. If you did a logistic regression, the values associated to the regression, etc. Okay, so at the end is basically, I mean, the model is a mathematical model that can be saved. Okay, and what you are saving are the information or the configuration of such model in such a way that you can open it again or loading it again, and you can use it. Okay, to make your predictions or to make your classifications or whatever. Other popular format, okay, this is the ONNX, that is Open Neural Network Exchange. Okay, and it's built to represent machine learning models. For example, to be honest, I have never used this one. I have never indeed checked too much about the configuration, but you can take a look. I'm not completely sure if it's completely close to machine learning to neural networks, or if other type of models can be saved. Here talks about machine learning and deep learning models, but from the context of machine learning, there are several algorithms far away or apart from neural networks that can be used. So to be honest, I don't know, for example, if a decision tree or if SVM can be serialized using this format, okay, or if it's more focused only to the concept of neural networks only. Let's start recording, and I will share again the screen. Okay, now you should be seeing my screen, right? Okay, can you confirm that see my screen?
Yes.
Okay, perfect, thank you. Okay, so well, I was explaining that in Python we have Pickle, okay, as one of the libraries that allows us to do the persistence of or serialization in machine learning, well, in general, of any Python object, but in this case applied to a machine learning model. Okay, and I was showing just this example where here we load the iris dataset and we train it with a SVM. And in the second part, what we have is the saving of the model. So we import Pickle, okay, and where in the first line we create the dump, okay, and in the second, what we are doing it is basically loading, okay, and doing a prediction again from the machine learning model that we load from the serialized file. Okay. You can also use ONNX in Python. Okay, here it's more or less similar code. In this case, we applied a random forest. So, for example, well, this is a thing that answered some of my previous thoughts. Okay, that in this case, for example, with a random forest, we can it's not just focused on neural networks. Okay, so we can store a random forest with a format ONNX. Okay, so we train the model, and in the second part we save the model, in this case using ONNX. Okay, and we see that we specify, for example, the file, and in the third part we use the model. Okay, it's that basically we open it again with the ONNX file and we use it. For PMML we have the same. Okay, we can create this object PMML pipeline. Okay, where we establish that this is in this case a decision tree. Okay, we train it, and here we save the model. Okay, with the sklearn to PMML function, where we basically this object pipeline we can save it in a .pmml file. Okay, with these arguments. So other options that we have in terms of the serialization is the porting of the programming language. Is the porting of the model to other programming language. As I explained you at the beginning in some of the problems of the machine learning, one thing that can be of interest for us is that maybe we are creating a model that will be used later in a different context with a different programming language. Okay, so in Python, for example, we have this sklearn porter. Okay, that allows to transpile the trained models. Okay, the scikit-learn models to C, Java, JavaScript, and others. Okay, you have here the URL to take a look to the sklearn porter, and here you have an example. For example, an example where we export a created model. It's a decision tree to Java. To be honest, I don't know exactly what is creating. I have never used it. Okay, this is some frameworks that I prepare for this class. Indeed, I'm really curious to see what it's creating. Okay, I would like to see exactly what is creating this porting of the model to specific programming languages. If I have some time at some point, I will do some tests to see the output. Okay, so other options is TreeLite, for example. That is a model compiler for decision trees. Okay, this is another option that you have in Python in order to export your models. In this case, for decision trees. And here again we have on one hand the loadout of the model. Okay, the exports and the use of the model once has been exported. Okay, making the predictions on the machine where you are going to deploy your model. For R, I also have some libraries. I will go a little bit more quick here because I to be honest, I focus more on Python, since I think that correct me if I'm wrong, but I think that most of the content that Ernestina or Antonio give you have been in Python. So I think that it's more interesting, but also knowing the popularity of R, I have prepared this material. So in the serialization, it depends on the specific libraries. Okay, but it's also possible to use Pickle to serialize R objects. Okay, and in terms of serialization, also you depends, as I told you, on the specific libraries. So for example, you have here some machine learning libraries, okay, that you can use in R, that they will provide you also some serialization options to save your models in files. Okay, so once we have our model ready in a file, the next step is going to the deployment itself. So once we are able to do the deployment, we can select some technology to deploy our machine learning model. Okay. Here we're going to show some of them that allows, on one hand, a local deployment. I mean, serving the model in our own machine. Okay, on our, I mean, not server, on our laptop or workstation or whatever, or even our own server if you have a server, or in a cloud-based or cloud server based environment. Okay, for example, serving our model in, I don't know, Amazon Web Service, or in Azure, in Microsoft Azure, or in IBM. Okay, indeed, I will show you. Basically, I think that I recompile finally 4 options. Okay, for cloud based. So the first one that is very popular is Flask. Okay, Flask is a framework, a web application framework that is written in Python, and it allows, I mean, through different modules, allows to create quite easy some applications without the necessity of worry too much about the details like the protocol management, thread management, etc. Okay, so here, for example, what I show, it's a very specific part where you can specify, for example, that you have a root, okay, a root in your web application that is /predict, that allows a post method, and what it's doing basically, it's just loading a model using Pickle. Okay, a model that has been trained and has been saved in a file, so using the serialization method that we saw before, okay, and making a prediction with the input values that you can see in the code. You see this variable equals request.getJSON. So once I receive the petition through the post interface, in this getJSON, I can get the JSON file that has been sent through this post petition, and I give this JSON directly as input to the prediction model. Okay, in this case, I'm assuming certain things like the input variables that I'm receiving at this specific moment are exactly the same input variables that the model is expecting to receive. This is really important because if you remember when we were seeing the architecture, there is a part that is the feature selection or the feature management or feature whatever, okay, that it's the one that is in charge of, among other things, making sure that the inputs that I'm receiving through my, in this case, REST API, should be the same or will be the same, that match exactly with the model and with the inputs that the model is expecting. Okay, in this context, you see that I'm sending directly the data. Okay, I received JSON and I send it to the model. If it's not the case that you need to make some conversions, you need to deal with this before. Okay. Other option, it's Django, that probably you already know. Okay, another web framework that allows the creation of webs very quick. Okay, and you can focus on creating your app and not doing too much. And we have more or less the same structure as we saw in Flask. Okay, we have the post request. Okay, that we can in this case we can program where we can get, for example, the different. In this case, what we are getting is the different variables that has been sent into the request, and we are putting them in different variables, in local variables in Python code. Okay. Here, what we have, for example, is that you can see that we do some pre-processing. Okay, we convert the variables, for example, to float values as the model is expecting float values. This is a very basic data pre-processing, okay, but it's part of these features that I explained you before, that, okay, remember that the input that you receive should be exactly the same as the input that the model is expecting, okay, and you need to do exactly conversions to be sure, okay, that it's working. And again, we have the model that has been saved in a pickle. Okay, we load it and we use the predict function in order to get a result. Okay, and for example, here we get the we create basically an object with the predictions that contains the result of the prediction, okay, as well as the confidence score, and this is what I'm going to give back to my post petition, okay, to the client. Some other frameworks that you have, okay, I didn't focus too much on these ones because I think that Flask and Django probably are I will say the main ones or the more typical ones, but there are others that you can take a look, like Bottle, Tornado, Pyramid, or Sonic, okay. In the context of air, this is probably the one that the one that I saw like more typical is Plumber, that I'm going to show you. I'm going to show you now an example. But also you can take a look to this web page, okay, model deployment in CRAN, where there is a lot of much more options that you can use apart of Plumber, okay. And in Plumber, well, basically what we have is more or less the same. We load the model, in this case from an air data file, okay, where it's supposed that the model has been serialized or saved. We predict, in this case, the value that I have received in this input data, okay. Here I have the output, and here, well, it's the same, but when I'm receiving the input from a specific petition, okay. You see that, for example, in the previous code there are some comprobations, there are some check-ins that allows to check that the input data that I'm receiving is exactly, okay, the ones that is going to be provided to the model, okay, because there are some, for example, parameters that should be between 0 or 1, and if not, the output of Plumber will be a 400 HTTP code as response, okay. And here in this screenshot, what I show basically it's using this Plumber, how to make a prediction, in this case through directly the API, the REST API that has been created. What you are seeing, if you take a look carefully, it's a petition, okay, using curl, okay, where I establish the content type, I establish that there is, in this case, a get petition, and I establish the different input variables that I'm going to send to the web service, okay. I saw at the end the value that is returning as output. In this case, the output is just a value, okay, of the classification, and it's not returning anything else. It's not returning any confidence value or anything like that, okay. Okay, so with this, what I have shown you is basically serialization and how to deploy machine learning models, okay, in an environment to use, for example, a web interface or a REST API interface that can be done in my own machine, okay, or can be done in our server or whatever. So I'm not using, let's say, commercial solutions or other solutions that are in the cloud, okay, to deploy my machine learning models. Now, I enter into the last part of the subject, okay, of the class of today, and I will show you different options that you have to create your deploy your machine learning models by using cloud-based environments, okay. Well, the first one that I want to show you is the Google Cloud Platform, okay, and it's, as you know, a service offered by Google, and it's a set of cloud computing services that, they have many things, okay. In terms of the deployment of machine learning models, it allows to deploy a trained model that you have trained, for example, in your own computer, and the creation of a REST API to query them, okay. And what I show you, it's some basic code, okay. Imagine that you have trained the model using this basic random forest classifier with the feed function to train the model. We export it using, in this case, an option that I didn't mention, that is joblib, okay, or pickle. It doesn't matter. At the end, the idea is to create a file where the model has been created. And what you can do is using let's say the the own applications of Google, okay, with the GS util, you can upload directly to your bucket, to your specific space that has been provided by Google Cloud Platform, the different files, okay. Well, here this booster is another type of serialization. At the end, you see it's the same, okay. It's using GC util CP to copy the model, okay, into the Google Suite bucket where you will have your model deployed, okay. And here you can, for example, use the G-Cloud application in the proper. I mean, sorry, today my English is. I need to think too much in the word. So the idea is that here you can test your model either in your machine, okay, or in the platform itself, okay, and you can test it with this application. And well, I just give you some of the documentation, okay, that is used in order to create the model and to deploy it in Google Cloud. Okay, Google Cloud for me is not one of the most easy ones. Okay, there are some constraints that you need to consider here, okay, depending on the type of machine learning model that you have created. If you have been using TensorFlow, or for example in scikit-learn you have been using XGBoost or any specific technique, that there are some things that maybe you need to specify. Okay, there are a lot of let's say configuration parameters that you need to take into account when you deploy. Okay, another option to deploy your models in a cloud environment, it's Amazon Web Services, in this case Amazon SageMaker. Okay, that it's a service that provides let's say all the tools that you need to build, train, deploy your machine learning models quick. Okay, so the idea is that SageMaker removes this heavy lifting from each step of the process to make it easier, okay, and develop high quality models. Here we have, for example, some example of code where we can again do several options, from reading a file that contains my dataset, to train it, okay. And for example, here you have another code to create, train, and validate and test the model, okay, setting the hyperparameters of your final model, and creating the endpoint, okay, to the model. The endpoint that at the end you can see also in your console, okay. In this console is when you can directly get the URL of the service where it has been deployed. Okay. Okay, and well, this is about the lambda function that I will omit. Okay, well, here is where you create the API, and you can see here all the structure. I will move because I think that it's no necessary to focus too much. It's just to show you that Amazon Web Service SageMaker is an option that you have, okay. And for example, here I'll shows once the API has been deployed how to test it with Postman, okay. That it's one of the options that I mentioned at the beginning, that of course in the day of tomorrow you should not be giving to a final user the service and the Postman application. Okay. Well, I think this is the third. Yeah, I don't know if I finally introduce IBM. Let's see if it's at the end. So the Microsoft Azure, okay, it also allows you to create a machine learning, to deploy a machine learning model. The idea is that you create your own workspace, okay, to deploy your model, and based on this, for example, we have here that we load the workspace, we train the model, okay, we save it, and we deploy it, okay. So the idea is that once I deploy it, I have ready my my URL that you can check here at the end that you see Boston Housing LR. If you click there is when you can see the URL that you are going to use in order to access the REST API. And I saw that I don't introduce finally IBM. I'm sorry. I will try to give you some hints also, because IBM Cloud also has a suite that allows the deployment of machine learning models. Indeed, IBM has I don't know if you know a software that is called SPSS Modeler. SPSS Modeler is a software that allows the creation of machine learning models, indeed using basically let's say a workflow based interface where you can connect different nodes and you can create your own machine learning model. And if IBM Cloud, for example, allows to deploy your model from this user interface directly. Okay, you can save the file, you can upload it to the IBM Cloud, and it creates automatically all the REST APIs. And it's quite interesting because it provides also some code snippets in Java, in Python, in R, in several programming languages, where it basically changes the URL with the ones that it's the one that has been provided to you after deploying your model. So with this code, it's quite easy to just run it and making a query against the deployed model. Okay, it's very nice tool. I will try to include it in the slides. Okay, and finally for R, to be honest, the only, let's say, not the only, but the most useful tool that I found is Shiny Apps. Okay, that it's a service that allows you to deploy your machine learning model using R. Okay, and I think that it's an interesting option. I'm not expert in R, so maybe there are other options. If you know some others, I would like to ask you to please share it, because probably I can enrich these slides for the next year. And finally, other probably useful stuff, it's this package that is Reticulate, that basically are a set of tools that allows, let's say, the interconnection or interoperability between Python code and R code, that also can be at some point very useful, because maybe, for example, you create your models in R and at some point you want to export or to do some things within Python using Python, and the use of these software packages can be useful. And finally, I have many sources and resources that I will give you. I will upload these slides to the Moodle, okay, during this afternoon after I upload the video. And there are many options that most of them I have already mentioned them during the class today, but there are other resources that can be useful and you can find interesting. So to summary, the idea is that now you should know, probably, as I said at the beginning, most of the things that maybe I mentioned here, you already know them. But the idea is that now you know how is the process of the model deployment, okay? How what things you need to take into account depending on the characteristics on the characteristics that your model needs to fulfill in terms of the data, if it's more static or dynamic, and in terms of, for example, the type of petitions. As I said, most of the machine learning models at the end are typically deployed as a REST API, okay? And this allows to query the model using just an HTTP request. I show you how to serialize the model and how to deploy your model both on your own machine with some tools like Django and Flask in terms of Python, and I briefly explained, at least my intention was basically showing you that in terms of cloud-based options, there are many options, being, for example, Google Cloud, Amazon Web Service, and Microsoft Azure, and IBM, that, sorry, I don't have slides for them. Some of the main options that you have in cloud environments, okay? I didn't focus too much on explaining the processing, the tools, because I think that the best option that you can do at the end is playing a little bit with the platform to see how to deploy the model. Also because there are nowadays many tutorials that you can follow, and probably you can deploy your model quite easily without not many problems. And from my side, this is all. I mean, we finished a little bit before 5, but it doesn't matter, I think. I don't know if you have any question or any comment that you would like to discuss before leaving, or if everything is more or less clear. At the end, I speak a lot and I didn't interact too much. Sorry.
No, thank you so much for everything. It was so cool.
Thank you. Okay, so if there are no questions, thank you very much. I will upload the video. Okay, I will try to cut this part when my connection was down. Okay, and upload everything, and I will upload the slides also during the day. Okay. Okay, thank you very much, guys. See you.
Bye.
See you. Bye.